Hi students, I'm sure you all are doing great. So now we have the next video, that is part 2, which is related to describing motion around us. Part 1 was from question 1 to question number 10. Now part 2 video, it is related to describing motion around us, chapter number 4 and questions 11 to 16. So let's understand question number 11. The student said, the earth moves around the sun. Now, in this context, discuss whether an object kept on the earth can be considered to be at rest. Now, the question is an object on earth at rest? A student says, the earth moves around the sun, which is given in the question. So, we need to understand that motion is always relative. If we take the earth as reference, objects on the earth like book or table or anything which is lying, they are at rest. But if we take the sun as reference, then earth is moving. So everything on earth is also moving with it. An object on earth can be considered at rest with respect to earth. But it is in motion when we are talking with respect to both, whether we say sun or we say earth. Hope question 1 was clear, because with there you just have to write the explanation part. Question number 12. The velocity time graph from 0 second to 120 second for a cyclist is shown in figure 4.30. Just wanted to give you an idea that figure 4.30 is the same number which is mentioned in your textbook. Shade the areas representing the displacement of the cyclist. Part 1, while cyclist is moving with constant velocity. Part 2, when the velocity of cyclist is decreasing, and also calculate the displacement and average acceleration in the 120 seconds time interval. So look at this graph. First part, displacement during constant velocity. So on velocity time graph, which you can see it on the screen, constant velocity, when we talk about, it is basically the horizontal straight line. Okay, that's the horizontal straight line which you see it on the graph. Now, how to calculate the displacement? If you have done the previous questions, you will come across that displacement is basically area under the graph. So whenever you have to calculate the distance related to velocity time graph, please students remember, we always calculate the area. We have to find out the area under the graph. So second part talks us that when the velocity of cyclist is decreasing, that means displacement when velocity is decreasing. So decreasing velocity is the sloping downward line. So if you see this line, children, this line, I can quickly make this one. So this is sloping downward line. And displacement, again, it is area under the sloping line. So how are you going to calculate this? So area under the sloping line. Hope this is making sense to you all. Let's go further. Question number 13. A girl is preparing for her first marathon by running on a straight road. She uses a smartwatch to calculate her running speed at different intervals. The graph 4.31 depicts her velocity versus time. Estimate the running distance based on the graph. Now, look at this graph. This is your velocity time graph. Okay. Now, to understand this, first you need to know that velocity is in kilometer per hour, which is given. Time is in hours. So, how you calculate area under the graph? That is the distance, or the distance to be calculated. How? By finding the area under the graph. This you have to remember, students. Now, distance will be what? Area under the velocity time graph. Let's understand this. So, area under the graph, that means what? Again, I'll repeat it. It is distance, which is in kilometer. Now, from 0 to 1, students, could you see the graph here? from 0 to 1. If I draw this here, this part, okay, this part, can you see it on the screen? So to calculate the distance, we have 7 into 1. So 7, and from 0 to 1 it is 1. So 7 into 1, that is 7 kilometer. Next is from 1 to 2. Now, as I explained to you in the previous graph as well, previous question as well, that to calculate the distance, what do? We take the average velocity divided by 2 into time. So 7 plus 7.5 upon 2 will give you 7.25 kilometer. Likewise, you have to take from 2 to 4 hours, then 4 to 5 hours, 5 to 6 hours, and 6 to 7 hours. Now, after you have done this, what you do? You just have to add all the distance. That is 48.8 kilometer. So once again, to find the distance, looking at the graph, children, don't confuse yourself. You just look at the graph, understand the concept that area under the graph is basically the distance. So to calculate the distance, what do? You are going to divide it into parts. Once you divide it into parts, you will get the distance and you calculate by adding it. So that will be the total distance, 48.8 kilometer. Hope this question is clear to you. Let's understand question number 14. Now, on entering a state highway, a car continues to move with a constant velocity of 6 meters per second for 2 minutes and then accelerates with a constant acceleration 1 meter per second squared for 6 seconds. Find the displacement of the car on the state highway in the 2 minute 6 seconds time interval by drawing a velocity time graph for its position. Now here you see, children, I have given you the graph, that is your velocity time graph. Now what you have to do is you need to refer the question while seeing the graph, and I'm very sure you will understand. I have mentioned, I have labeled everything according to the question. So displacement using velocity time graph. So what is given here? Constant velocity, that is 6 meters per second for 2 minutes. Request that you have to convert minutes into seconds. So that is 120 seconds. Acceleration 1 meter per second square for 6 seconds. So once again, the horizontal line, which you can see it on the screen, that is the constant velocity. It is 0 to 120 seconds. From 120 to 126 seconds, again you see it is a sloping line, which is a uniform acceleration. So that rectangle area, can you see this rectangle area? So you have to calculate 6 into 120. So how we got the 6 into 120, children? Area of a rectangle, because we have to find what? We have to find the distance. So area under the graph. So first graph is this one, rectangle, okay? So it is length into breadth. So what is the length here? If you see, it is 6. And what is the breadth here? 0 to 120, that is 120. So 6 into 120 will give you 720 meter. Now final velocity after acceleration. So you can use equation of motion, substitute, and you will get the final velocity. Because here, if you again, let me take you to the question. Find the displacement of the car on the state highway in the 2 minute 60 seconds. Okay, that is your 120 seconds time interval by drawing a velocity time graph. Now area, if we have to find the trapezium. Now what is the area of the trapezium? That is sum of parallel sides upon 2 into distance between them. So what is the distance between them? That is 6, which we know it, right? And then area of trapezium with sum of parallel sides. So it is 6 plus 12. So if you see this part, 6 plus 12, and the distance between them, this is the distance between them, that is 6. And when you calculate this, you are going to get 54 meter. So now what is the total displacement? 720 plus 54, and that's your answer. So you need to add it, and that's your answer. So request children that please pause the video, draw the graph, understand, jot down everything, and I'm sure you will understand how to solve these type of numericals. Let's understand question number 15. Two cars A and B start moving with a constant acceleration from rest in a straight line. Car A attains a velocity of 5 meters per second in 5 seconds. Car B attains a velocity of 3 meters per second in 10 seconds. Now again here you need to plot a graph, that is velocity time graph, for both the cars in the same graph. Now using the graph, calculate the displacement mentioned in 2 time intervals. They have given us the hint as well. Calculate the acceleration in both the cases. Then calculate the velocity at 5 instants of time to plot the graph. Let's understand this. Yes, so this is the graph, velocity time graph of car A and car B. So this blue line, what you see, that is your car A and car B. Now for car A, the velocity is given. Again, you just don't have to, confuse yourself or get worried about it. The important part is first to write what is given. So for car A, the velocity is already mentioned, that is 5 meters per second in 5 seconds from rest. So it is from rest, so now you all know when it is rest, that is u is 0. So you have to calculate the acceleration by substituting the value. For car B, it is mentioned velocity is 3 meters per second in 10 seconds. Again, it is the rest position, so u is 0. And you will get the second acceleration for car B, that is 0.3 meter per second square. Now velocities of car A, so how you have to calculate, here you need to plot the graph because they have told us to plot the velocity time graph for both the cars in the same graph. So likewise you have to take time t, then velocity v, and then likewise velocity of car A. So for time t and velocity v for the car B. So you have to just substitute the values, children, and then you can get the answer. So for car A, now we also have to calculate the displacement. As I've explained to you, it is area under the graph. So in this, if you see for car A, we have, what is the area of a triangle? Half into base into height. So what is the height here? If I quickly mark it, so that will help you to understand what am I talking about. This part, yellow line, could you see? So I draw this, let me use the other color. So this part, I'll just quickly draw. Yes, so half into base into height. So what is the base here? That is half, that is base is 5 into height, that is again 5. So you calculate, you will get 12.5. For car B also, again I draw it, again the right angle triangle, half into base into height. So you take height, which is 3, so half into 10 into 3, and then you calculate, you will get the answer, that is for car B. Next is question number 16. Rohan studies science from 6 p.m. to 7:30 p.m. at home. Consider the tip of the minute's hand of the wall clock. During the given time interval, what is its distance traveled, displacement, speed and velocity? The length of the minute's hand is 7 centimeters. Now, what is given? The time interval is 6 p.m. to 7:30 p.m. Now, children, you need to convert it into seconds, but before that, you need to convert it into minutes. That is 6 to 7:30 p.m. That is 90 minutes, which is 5,400 seconds. Now, what is the length of minute hand? Now, when I say minute hand, that is the radius here, which is 7 centimeters. That is also given in the question. So we need to calculate the first one, the distance traveled. So the tip of the minute hand, how does it move? It moves in a circle, which we know it's a circle, it moves round. So in 60 minutes will be 1 full revolution. In 90 minutes, it will be 1.5. So what is the distance now? So distance will be total circumference covered. And what is the circumference of a circle? That is 2 pi r. 2 pi r is the total, is the circumference. Okay, so you need to remember circumference of the circle is 2 pi r. And we calculate with what? We multiply with 1.5 revolutions, which is 1.5 into 2 pi r. You can give answer in pi, that is 3 pi r. So 3 pi into 7. Now what is 7 here, children? That's the radius, which is minute hand. So you get 21 pi. After that, approximate answer will be 66 centimeter. Second is the displacement. Now displacement, now at 6, the minute hand is where? I think we all know how to read the time. So it is at 12. At 7:30, minute hand at 6. So initial and final positions are diametrically opposite. So if you see it at 6, the minute hand is at 12. And at 7:30, minute hand is at 6. So diametrically, they both are opposite. So what is the displacement here? Diameter is 2r. Why we took 2r? Because diameter is twice of the radius. So 2 into r. And what is the radius? That is 2 into 7, which is 14 centimeter. So displacement is what? 14 centimeter, which is downward direction. Now speed is distance, time into distance. Now here, if you see, we calculate the speed also. Children, here there is slight error for speed. So we calculate the speed, that is distance upon time. So once we calculate, you will be getting 0.0122 centimeter per second. Further, we also have to calculate the velocity, but you know what is velocity? That is displacement upon time. So we've already calculated the displacement and time converting into seconds. If you want to leave it in a fraction by reduced form, which is given in your textbook, that's fine. If you want to give it in the decimal form, that also is accepted. So direction will be from 12 towards 6, which is downward, and the velocity, as we calculated, 0.00259 centimeter per second downward. Hope these questions were clear to you, and still you need more of questions related to numericals, which will soon be uploaded so that your concept will be clear. So thank you so much, children. I've completed my 2 videos, which is video 1 for part 1 was for your describing motion around us from question number 1 to 10, and this particular video is part 2 from question number 11 to 14. So please revise the concept, practice the questions regularly, and you will find them easy with proper understanding. And also don't forget to like, share and subscribe for more helpful lessons. Next video is on the next chapter, how forces affect motion. Thank you so much. Take good care of yourself. God bless you.